This video is going to provide just a brief introduction to Java's JPA, or Java Persistence API. And JPA is basically a facility that provides an object relational mapping so that you can create a Java class and you can map that Java class directly to one or more tables in a relational database. So to begin with, we want to verify that we have access to a database. So we're going to go to the Services tab in NetBeans, and we're going to click on the database, and you should be able to see a samples database that's a JDBC Derby database. Right-click on that and select Connect. This database was provided in the download of NetBeans JEE version. Then we can expand on these nodes and we can get a list of the tables that comprise the sample database. Don't be concerned if you have tables. I have some tables listed here that you don't have in your sample database. I've added a few of my own. We're able to right-click on any of these tables and view data. And so now we can see the type of data that's being stored. We can expand the node and we can see the list of columns for that specific table. We can also see the data that's stored in each of those columns. And we can infer some business rules or some validation rules based off the data that we see. Generally, if we're going to create an application for a user, the user helps us to understand the business rules that are associated with their data. But because we don't have an active user, we're going to infer our business rules based on the data that we see in this table. So we can see that a zip code is 5 digits, meaning that they don't require the optional 4-digit extension on the zip code. We can see that the radius can be negative or positive. We can also see that area length and area width is always positive, so we don't see any negative values. So from that, we're going to state that our business rules, that our zip codes are 5 digits, that our area length and our area width can't be less than 0. So now let's begin by creating a web application. So we're going to go to File, New Project. We're going to select Maven, and we're going to select Web Application. We're going to call this application Product Management. We're going to specify where we want on our local drive, where we want that project to be stored. And we're going to specify a group ID. In this example, EDU USD CSCI product. And we're going to just verify that we have selected for our server, our Glassfish server, and this is where our application will be deployed. And then we select Finish. The next thing I want to do, which will come into play later, but I want to configure the properties for my project. So I'm going to right-click on it and select Framework. I'm going to add a framework that's going to be Java Server Faces. And the component is going to be Prime Faces. I'm doing this now so that when I get to a point that I want to develop the user interface for this application, that I have some built-in functionality that makes that development a lot easier. Now I can right click on this and just run it, and that's just to verify that it's deploying to the server correctly. And sometimes this takes a little bit of time to get going because our Glassfish server wasn't running, so it has to start up the server and then it has to deploy the application. And you should have something like this come up in your browser. You can click the prime faces and it builds just a default prime faces template. And again, we'll talk about that in another video. So now the next thing I want to do is I want to create a plain old Java object, a Java class that can map onto this micro market database table. So I'm going to right click on my project and say new other. I'm going to select persistence and I'm going to select entity class from a database. So I need to select what database do I want to use for this mapping. It could be a MySQL database, an Oracle database, but in this example, we're going to select our sample database. And the sample database lists all the tables that we have available to us. I'm going to select the micro market table. So what I'm asking NetBeans to do is to create a Java class that represents or maps to this micro market table. I can give this class any name I want. And what I generally do is put an entity extension on the class name just so that when I'm looking through my source code, any source that ends in entity, I know it represents a persistent value in the database. And I just check to make sure this is the package that I want to use for my Java class following our coding standards. And I want to specify that my collection type is lists so that later on when we start actually getting data out of the database, if we were to do a select all, for example, that all of our micro market objects would be stored in an array list. So NetBeans has created this entity for us. And really, this is simply a Java object, just a Java class, but it has some very strange annotations. The first annotation you see is the entity annotation, and this tells our Glassfish server that this Java class is an entity that maps to a relational database. This specifies that this entity maps to a specific table in the database, and we specify the name of the table. So the name of our class is micro market entity, again following our coding standards, but the actual name of the table in the database is micro market. So that's a mapping. It maps our class onto that table in the database. These are some define name queries that NetBeans creates for us, which are SQL-like queries that we'll use later on. Our micro market entity, our Java class, has attributes. It has the attribute zip code. It has the attribute radius. It has the attribute array length and the attribute array width. And this maps to the columns in our table. So for each attribute in our class, we have a column annotation that says what is the name of the column that this attribute maps to. So here are attribute column mappings. The other thing to note that's really important is every entity, every class that's annotated with the entity annotation has to have an ID annotation, because every table in the database has to have a primary key. So if we go back here, we can see that zip code, and we can even look at the properties, is the primary key for this table. Therefore, in our Java class, that has to be annotated with the ID. We're also adding an annotation saying it can't be null, and we're saying that it's not optional. So it's basically, we're saying it's required, it can't be null. One of the things that's available to us when we create our entities is that there's a validation annotations that we can use that can help us enforce business rules. Now, if you recall, we talked about the business rules for our micro market table. Zip codes have to be 5 digits. Area length can't be negative. Area width can't be negative. So what we're going to do is we're going to specify those rules right here in our entity by adding validation constraints. So for example, NetBeans put this one in for us, and it says the size of zip code, the minimum number of characters. Size with a string represents the number of characters. So it's saying that the number of characters, the minimum is 1 and the maximum is 5. Well, we can actually be more specific than that. We can really be specific about the type of zip code that we're going to allow in this field. So we can use a validation constraint using pattern. And we can use regular expression. A regular expression. And we want to think about what regular expression would represent a zip code. Notice that it's saying that it can't find the symbol pattern. I can right click on this. Oops. And I can import JavaX validation constraints pattern. So we know our zip code has to start with a digit, and the digit is 0 through 9. And we're only allowing 5. And that's our regular expression where we're saying that it's 5 digits. If we wanted to be more specific, we could say that it was going to be the first digit is 1 through 9, and then all the following digits can be 0 through 9 if we want to specify that a zip code can't start with 0. The other thing that we want to add to this is we want to add a message. What message do we want to give to the user if this validation constraint fails? If a user tries to enter a zip code starting with 0, or a user tries to enter a string that doesn't represent a valid zip code, we could say something like zip code must be 5 digits and cannot begin with 0. So we can put our user-defined error message in here for information that is invalid entered in a zip code. We wanted to specify a validation constraint for area length. So we want to say the minimum value of an area length is 0. Can't find symbol. We want to import JavaX validation constraint min. And we want to do the same thing for, and this is another place where we want to put our own user-defined message. Area width cannot be less than 0. Area length cannot be less than 0. So now we've considered the 3 business rules that we identified are important when creating a micro market entity. One other thing that I think is really important to put into a micro market entity class, or really any entity classes, is to make them comparable. You want to do this if you think that there will be a time when you'll want to be able to sort your micro market entities. Notice that you get an error message saying micro market entity is not abstract and does not override the abstract method compared to. So any entity, any Java class that's comparable has to override the compare to method. The compare to method is a method that returns an integer and it compares this object with any other like object. And compare to will return a negative number if this object is less than another object. It'll return 0 if they're equal, and it'll return a positive number if it's greater than the other object. It turns out that you need to decide how you're going to compare. You have control over how you define what determines a micro-market equality, what makes them equal. Well, in our case, we're going to say that 2 micro-market entities are equal if their zip codes are equal. And the Java string overrides the compare to method. So basically, all we have to do is return this zip code, compare to the other zip code. Well, we need to worry about whether or not we have any nulls. So we're going to say if this dot zip code is equal to null and the other dot zip code is equal to null, we're going to return 0 that they're equal. If this zip code is equal to null, we're going to return a -1. Basically, we're saying that this zip code, if it's null, it's less than the other zip code. And then if the other zip code is equal to null, then we're going to return 1, which is saying that it's greater than the other zip code. The one other thing I'm going to do is just change the toString, and I'm going to have it just return zip code rather than all the other stuff that NetBeans added. And we can see that the equals method determines that 2 micro market entities are equal if their zip codes is equal as well. So that's just a really brief introduction to JEE JPA, or Java Persistence API.